If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon. Hey everyone, how's it going? My name is James and I'm the Bald Engineer. Welcome to a live stream. If you can hear me okay in chat, please let me know by letting me know one of your favorite components, and then we can get going. And if you couldn't tell, we're going to be talking about oscilloscopes in tonight's stream. Oh man, all kinds of stuff we got to finish getting set up, but I was really excited to get started, so let's get going, right? Where did this one come from? I think it came from down there. Thermistor, awesome. If I recall, the original NES used the 6502 and Game Boy used the Z80. Yes, that's correct. Which I always thought was interesting that there were so many NES ports from the Game Boy, from the NES to the Game Boy, that they had different CPUs, but I think their picture units had similar registers, so it made it a little bit easy. Okay, everybody be quiet, see what he does. yeah, no kidding. Okay, first, hello to everybody in chat. GD, good to see you. Babin, always good to see you. GB, I liked your point about the trivia question on the one soldering. If I remember later, we'll actually add to that to the trivia. Mike, good to see you. Circadian, always good to see you. Saul, better call you. David Boyd, I think I saw you earlier. I hope I said your name correctly. For those of you who haven't caught on, I am in the new lab. I haven't finished with the lighting or the sound yet. In fact, I only have about half of the sound panels up right now, which means it's still going to echo a little bit. But I figured let's get down here and get started. And just to FYI, behind the scenes, the stuff behind me is actually temporary. I have other plans for the background, but I decided to put this up because I don't have time to get to all that yet. But big thing I really wanted for a long time was I wanted like a stand-up table so that I could do more of a presentation and talking from here. And then you can't see it tonight, but I have a whole nother section over there where I'll actually have a desk similar to what I used before. And then on the other side of the lab will be actual lab benches that come on Monday. So there's a small to medium chance Wednesday or Friday we might actually do a bench building stream, because why not? So does Y count? Yeah, okay. I get it. Y of the component. You're very clever, very clever. The big HP scope, I have the one on the bottom. Yeah, so this one on top is actually a scope and logic analyzer, and the one on the bottom is a digitizing scope. Over here is my trusty Rohde & Schwarz RTM 3000 that shows up in most of my videos. I am going to turn this one on today just to verify that the power works, and to get a good baseline for the peak-to-peak measurement off the waveform generator. But I already know this works because I've actually used it. I was using it earlier today. What I'm really interested in seeing is, do the rest of these scopes work, especially the ones with CRTs, which I think that's the only one with an LCD. And you guys can't see it right now anyway. I also have the big 7704, which would probably be very last, because if there's something wrong with that, there's probably going to be magic smoke on that one. So I want to be careful. Keep the mini Tesla coil. Oh yeah, I forgot about that. Yeah, actually one day we're going to do a stream where I repair the board on that one. So what ended up happening is I built the whole thing and I soldered the control board for it. And frankly, I soldered it after I went to a happy hour. And the next morning I thought, you know what? I did fine. I'm good at soldering. I'm not. And turned out there's IGBTs that control the high voltage to make the arc, and the IGBTs are shorted, and so it actually blew out the trace that ran underneath the fuse. And so I thought it was hilarious that that the short caused the trace under the fuse to blow up. The fuse is fine. I have an extra fuse. So I got a replacement board for that, and we'll replace that at some point. Cool, Siglent SDS 1104. I don't know the Siglent product line that well, but I do believe it's, I think that's a pretty good one. So GB, you've got a 16500. Actually, I have a 16500 as well. I featured it in the Element 14 video on Logic Analyzer Basics. And if you remind me in Discord, I'll send you a link to that. And in fact, when I was setting all this stuff up, I realized I haven't found that one yet, but I suspect I know which box it is in, because there's an odd shaped box that I haven't, like, when I look at it, I didn't know what it was, but I'm thinking it's probably my 16500. Which has two different acquisition cards, and one of the cards has a bad ASIC, which is a bummer because it doesn't work all that well. But fun fact about the 16500, that was the first logic analyzer I worked on when I left school, or when I graduated, because I worked as an apps engineer for HP and Agilent. And the, what do you call it? So I supported the logic analyzers, and I supported oscilloscopes, which is sort of what I do today. And so the 16500 was the very first one I worked with. Thing is, my manager at the time was one of the software developers for the 500, and I was, long story short, one day I was complaining about how this piece of software was kind of written bad, and I said, I just don't understand, why would somebody write it this way? They should have normalized the data so that any tool would work. Who in their right mind would make the tool only work with, or the data only work with one tool? And then he got really quiet and he's like, well, you should probably remember that I used to work on this code and it was probably me that wrote that. And I thought, yeah, I just called my boss out. That was not a good idea. So, okay, let's start making room. Thank you. Circadian Rebel, you made the switch over to Twitch. Welcome. I would say welcome to the stream, but you are definitely a veteran. You know what? At some point, I need to grab some cleaner, because some of these have never been wiped down. And so we should clean them up. And so I think what we'll do is let's start over here, because I think that shows up on the camera. So the best place is going to be right here. Okay. So what I'm going to do is let's move, what we'll do is move these out of the way. So maybe we can start with this one, and then I gotta get, and it is Friday, so cheers. Okay, we'll open up the, what you call it? What do you call that? A function generator. Make sure that's working. Don't need this anymore. And then we'll get to this analog scope, which is actually really cool because it has a Z-axis output on the back. And that is important because I have a set of boards coming for the Scope Vectrix. Or a thing called Scope Vectrix, which is a recreation of the Vectrix control board, where you use an oscilloscope as the screen. And so that is an example of a scope that will work with. So I'm pretty excited about that. What in the gigawatt is a Z-axis? So Z-axis is used in XY mode. To explain more. So normally a scope graphs voltage versus time. And so in XY mode, X, it basically graphs X versus Y. So as you change a voltage on either input, it moves the dot around the screen. The Z input allows you to blank or change the intensity of the Z axis. So you can turn the dot on and off. And so something like the Vectrix needs that so that it can, say, draw a vector, turn off, and then move the beam and draw something else. So Z on an XYZ scope allows you to turn the beam on and off. Or some scopes will let you change the intensity as well. Like I want to say some digital scopes support XYZ, and those tend to just shut it off. Okay. All right. So what I just now realized is I don't have any power cords. And let's see. And if I put power over here, that's going to be a problem because the other camera is pointing in. That's going to be in the face of the camera. So we're going to probably end up having to move chat in a future video because chat really needs to be on that side of the screen. But I'm not going to be messing with that today. We're just going to live with what we got. But note it for future videos. Well, actually, long term, my plan is to only stream to Twitch and then do recorded videos to YouTube. And so if I do that, then we won't even have the on-screen chat anymore. Okay, let me go off screen for just a second because I need to grab some power cables. These look really good. All right. Okay, so let's get this powered up. Okay, plug this one in, and then we're going to plug in the next one. All right, let's do this one. And turn that off, plug that in. Okay, turn this on. Awesome. Okay, so maybe let's see what happens if we go to here. Okay, I think we can make, so okay, that's going to work out. I think that's going to work out. So let's do that. So function generator is functioning, and let's turn the scope on and see if it boots. So this is a HP 54501A. And what I wanted to see is if we could go get the data sheet for it. Ooh, so if I'm over here, we lose the chat, huh? That's interesting. Let me see if I can fix that real quick. Because if there's nothing going on over there, we might as well. Okay, so we need this. We'll take the service manual. I was hoping for just the, okay, front panel operation. That could be good. Okay, so address, we'll do norm@cheers.com. No way, Jose. Remember me. Okay. And then I should be able to just reload this one and get it to load. Okay, and I'll save those in just a second, but I want to go back to this other scene and see if we can't get chat to work real quick. So which one is that? That was this. So where is chat? There it is. Okay, mucho better. Yeah, okay. Oh, gosh. Yeah, now that I can move all around, I keep, not sure that's going to work out to be the best. I'm going to have to in one of these streams, we're going to have to build some robots because I'm doing too much physical work. Not that I'm opposed to physical work, just that I'm doing too much of it at the moment. Huh. That's not good. Hey, Flask, how you doing? Good to see you again. Hey, Brian, nice to see you as well. Oh, this is the one that's broken. That's why it stopped. Okay. I feel better about that. Okay, so I think what I'm going to do is let's see if we can't get this to be a little better on screen. Oh, you know what? I would like to stand next to it, so I should probably move that back. Yeah, it is still a little bit on the dim side, huh? Let's think, what can I do to solve that problem? If I reduce the light on it, and then let's open up the aperture, try to get it to focus on it. Okay. That might be the best that I can do. Let's see, can you see that at all? And then the next thing I'm going to play with is, let's see if I can get it to synchronize. That's not it. There we go. Yeah, we'll go a little bit off of the refresh rate and see if that gets a good screenshot. Yeah, that's pretty good. Bald engineer to be replaced by bald robot. Oscilloscopes after dark. That's what I should have called the stream. Darn. Okay. So next, let's find a BNC cable, like the one that I had put right over here for unknown reasons. And we'll hook this up to here. Okay, so I'm gonna have to turn this stuff off so you guys can see, but that's okay. I think we're set up for that already, so that shouldn't be a problem. And then we're gonna, okay, first thing I'm gonna look for is, does this have a default setup? I see auto scale. These are all measurements. Maybe utility. No. Okay. Okay. So let's just do clear display. This should be channel 1. Wow, this is channel. I didn't realize this was a 4 channel. I thought this was only 2. Interesting. Okay. These are now in my way. I did not plan that far enough ahead. Okay, so let's go to here so you guys can see that a little bit better. And on the function generator, it's set to 5 volts peak to peak. I'm going to change that to 1 volt peak to peak. So, oh, that was frequency. So let's go amplitude, 1 volt peak to peak. Where's the volts peak to peak? Here it is. Changed my mind on that again. We're going to do 500. Nope, that's not what I want. Just click OK. I want 500 millivolts peak to peak. So that should be 1 volt centered around 0. And then the frequency, you can't see that on the screen, but oh, I'm going to do a frequency of 1 kilohertz. It's this one. Okay, and then the thing that always messes me up, make sure I turn on the output. And so we should actually be seeing something on the scope screen now. So what I want to play with is, where is my, uh-oh, I'm a little bit worried. We should be seeing something. So let's go channel. So channel 1 is off. Okay, channel 4 is on. So I got to go over here, and then I think I hit that. Nope. I wonder, maybe this one turns it off, and then we can turn channel 4 on here. Or, I'm sorry, turn channel 1 on, and our volts per division should be like, what is it? Should be 10 millivolts per division, or 100 millivolts per division. This should be 8 divisions, so that'd be 800 millivolts. Okay, let's go 1 volt per division. We should still be seeing something. A little bit concerned. Hey, Game Tech, good to see you. Yeah, the thing you have to be careful, like obviously this is a used scope, and something you have to be really careful about is especially used digital scopes, if they fail, there's not a lot of stuff you can change because it's all ASICs. And so you almost always have to find another scope to be a donor scope. So 1/8 to the third, 1/10 divided by, so we need 100 microseconds per division. So where's my horizontal? Go to time base. There we go. Yeah, we were just way zoomed in, so there's no hope of it finding the signal. All right, so now we can go back to the channel. Let's increase our volts per division. And then I'm going to not dial in an offset. This is actually what I had meant to check on the other scope, because I wanted to make sure that what came out of this guy was a really good signal. And so what I'm worried about is this almost looks like it's slightly more negative than positive. And so I don't know if that's an offset in the scope or is it an offset from the function generator. So one thing we can do is let's go take a look at channel 2 and see what it looks like. So let's turn that channel off, turn that channel on, turn this on, and then change its offset. Oh, change its offset to, oh, no, it should be 0 volts. I meant to press volts per division. And I'm on channel 3. God, I am just all over the place. Okay. So that looks about the same. So trivia question for the chat is, before we had a stable waveform, and now it's like bouncing all over the place. Why is that the case? This was made when HP really shined with their digital stuff. I mean, you could argue, so HP arguably made the first digital oscilloscope. And then I would say when Tech came out with the DPO series, the digital phosphor oscilloscope, which my 7704 is a precursor to, you could argue that that's when Tech really hit their stride with digital scopes. And then today, Keysight, the replacement for Agilent, I mean, they're the ones with that $1.5 million, 100 gigahertz analog, 250 gigasample per second digital scope. I mean, they're still doing really well with digital. Fortunately, other companies, like I work for Roden and Schwartz, and we're doing a ton with digital processing while doing acquisition. And so we're, you know, there's other companies doing stuff there too. And TC Evans is correct. And oh my God, what the hell, blah, blah, blah. Okay, yeah, you guys got it. The trigger was, we had set the trigger on channel 1 and then we moved to channel 2. So now the scope is still an auto trigger, which means it looks for a trigger condition. If it doesn't see it after a specified amount of time, it just dumps the buffer and then goes again. And so that's why we're getting it desynced, so to speak. So let's go back in, and now we got to find our trigger menu, and we can see trigger source is 1, 2, 3. So trigger source, change to channel 2. And yeah, it still looks like the positive half has a little more signal to it. Let's do a, let me see, can I just do this for Vmax on channel 2? Oh, that's cool. So if you don't see it, so on the keypad, there's blue measurements, or blue text for measurements, and so I just did Vmax. So I'm going to try Vmin. Where's min at? Well, max is there. Amplitude min, right next to it, James, duh. So Vmin, and now it's asking, well, what channel do you want to measure? So we're on channel 2, so let's say channel 2. And so, yeah, so we are at least measuring some asymmetry. That's interesting. Let me go back to the channel and make sure that our offset is 0 volts. That's interesting. So why do we have a, oh, okay, that's not what I thought. Okay, so we'll have to see if that carries through on other scopes, because then we know that it's the frequency generator. But I'm kind of surprised. I don't think this generator has an offset. I think it's actually pretty stable. Let's actually double check something on here. Oh, you can't see this. Yeah, my offset on so I just looked at the offset on the frequency generator, and it is definitely set to 0. So there's something else going on. I'm just not sure what, but that's cool. Okay, so let's go ahead and move over to channel 3, and then let's turn this one off, turn channel 3 on. Okay, I'm just gonna say that looks roughly correct. And then let's go to channel 4. And channel 4, oh, that's channel 3 I'm still playing with. Okay, whew, I was getting nervous there. So let's change the trigger so this is stable for purpose of the display. So what's going on right now is I'm overdriving the display. Connect probe to DC ground. Oh yeah, let's try that. Let's just ground the output and see what happens. Because that'll give us an idea of something weird is happening. Well, I mean, the problem with looking at like the sync signal on the scope itself is we don't know if its signal is any good, unless you mean the sync signal from the generator. But the thing is, we're going to look at like 5 more scopes. So we're going to use the approach of if one scope does it, then it's probably the scope. If 2 scopes do it, it's likely the generator. If 3 scopes do it, then we know it's the generator. But at least we have sort of a baseline now that they're not the same. So what I was going to say is notice how this waveform looks kind of funny. And it's because we're over, oh, that's the wrong control. I want to go to channel, volts per division. And so now we're not overdriving that amplifier. Now, one thing, let me think about this one for a second. Let's go look at the data sheet real quick. Sync from the generator, okay. Let me pull up the data sheet, and then I'm going to switch to my laptop because I want to look at something. So let's do laptop and B-roll, and then I will cinch this up a little bit. Okay, so what I want to see is this should have the specs in it. And because I want to point something out, but before I point it out, I want to make sure I have the numbers right. Okay. Oh, that's not good. Why is that flickering? That caused us problems yesterday. So let's see. So the bandwidth is here. Vertical resolution is 8-bit. What I'm looking for is sample. Yep, that's what I was looking for. So let me zoom this in a little bit. So this is a really good example of an oscilloscope that has an analog bandwidth of 100 megahertz, but its digital sampling rate is only 10 megasamples per second. And so, boy, that is annoying. And I'm going to disconnect that right now because that was causing us so much trouble yesterday. I thought I had a solution to my laptop messing up the capture card, but maybe not. So what's really critical about that 10 megasamples per second is that even though the analog front end, which is basically a low-pass filter, like a single pole low-pass filter, will allow up to 100 megahertz of signal content to get in, there's only a 10 megasample ADC to sample it. And so what's interesting about that is, and I hope this shows up well on the screen, but you can actually see how we see the wave shape, but the dots are actually dancing all over the place. And the reason for that is because, this should be like, maybe if I come back to this one. And the reason for that dancing is because the scope is doing repetitive sampling. And so if we wanted to say debug a I2C signal or a UART signal with this particular scope, we would have to make sure that the signal was well below 10 megahertz, because even though the analog bandwidth is very high, the real-time sample rate is extremely low. And that's one thing you really have to look out for on older digital sampling scopes, is if it says it's a digitizing scope, there's a really good chance that the digital sample rate is significantly lower than the analog bandwidth, meaning it's not very useful for non-repetitive signals. In this case, we have a repetitive signal coming out of the function generator, so it works pretty well. But like I said, if we try to look at a serial signal on this scope, we're going to have a little bit of trouble. All right, so let me catch up with you guys. Or you're in an alternate reality where all your scopes are bad. I mean, that's the nature of metrology. You sort of have to assume something is correct before you can assume anything is correct, or before you can measure anything to be correct. So yeah. Well, I'm not saying that 10 megasamples is bad. What I'm saying is you have to be careful, because it can mislead you to the performance of the scope. Because like if we look at my modern scope, right, and this is let's take out the fact that I work for Roden and Schwartz, but as an example, so this is a 1 gigahertz analog bandwidth, but it has a 5 gigasample ADC. And so in this case, it oversamples the signal by a factor of 5, versus this scope, which is undersampling the signal by a factor of 10, or the front end by a factor of 10. And so it's not bad, you just have to keep that in mind. If you're looking at, say, like a clock signal, this HP scope would be perfectly fine up to, well, if it's a digital clock, it's going to be good up to 30 or 40 megahertz. If it's a sine wave, it's good up to 70 megahertz. So, okay. So let's see, we did some measurements. We looked at waveform. We looked at all the channels. So I think we're good on this one. So let's turn this output off. I'm going to go ahead and just turn this off since it's on top. Move this over here, turn this guy off, and we're going to call that scope good. Let's move on to another one. And just to make vendors fair, we'll move to a tech scope. Okay. So this one's going to be a TDS 350. Oh, I wanted to get something to clean this up. Let me grab a paper towel and my liquid gold, which I think I have some 70%. Because I just realized I don't think I have glass cleaner, since my glass cleaner was in an aerosol can and the movers confiscated all my aerosols. Yeah, even the cheap Regal, by the way, it's pronounced Regal. It's not Regal or Wriggle or whatever, it's Regal. Their base sample rate is 1 gigahertz. Their analog front end is like 200 megahertz, 300 megahertz. And so it even does a good amount of oversampling. What I would say about digital scopes, even as early as 10 years ago, but definitely 20 years ago, you really had to pay attention to what scope vendors were advertising, because just like that HP scope, it might be advertised as a 100 megahertz scope, but it's really limited. Versus today, where basically any scope from a good vendor, a tier 1 vendor, has enough sample rate for the analog bandwidth. So it's like, yeah, you should still pay attention. It's still an important thing to look at. But you're much less likely today, even from the cheap scope vendors, to buy a scope that is significantly undersampling for its bandwidth. Man, this thing is just gross. I think I bought this one at the flea market before I left the Bay Area. And if I did, this would be one that I must have only paid $20 to $30 for it. Because I bought a bunch of stuff from this place called HSC. And HSC was like this electronics surplus place that went out of business while I was there. And so I went in and I bought all of the instruments that looked interesting. So like the HP scope we just looked at, that one I got definitely as part of that sale. But yeah, I think I ended up spending, I hate to share this number, but I ended up spending like $1,000 on old test equipment that when I went and looked on eBay prices would have cost me $300 to $3,500 to acquire. So it was a good sale. Of course, that's also assuming that all the stuff now still works now that I've moved, because if any of it stopped working, then I guess you got to take that out of my calculation. Okay. Okay, I don't feel like I'm going to get tetanus now, so we can turn this guy on. Okay, and then let's get a better camera angle. Maybe something along these lines. See how well he turns on. Let's go to here. I want to go to there. So what do we got in the back? You can't see it, but I've got a Tektronix port with DC out, an RS-232 port, 9-pin, a GPIB, and, oh wow, it actually has a VGA out. What is this? It's a TDS 350? Okay. Wow, I didn't realize it had VGA out. I don't have anything that can capture VGA, but that's cool. Hey, Imp Pirate, thanks for the comment on the background. I'm starting to dig it myself. Hey, RJ, good to see you again. Always, well, I should say always good to see you. I mean, it is always good to see you. So, okay, so we got a little bit of banding. Let's see if we can find a shutter speed that it likes. That looks pretty good, I think. Now, does this one have an intensity adjustment? I don't think I see one. If somebody sees one, let me know in chat, and the next time I go over to chat, I will see if I can find it. But I'm not seeing anything to make it brighter. So I am going to try, let's see if we kill a little bit of the overhead light. Will that help? That might help a little bit. Can't see me as well, but I'm not what you're here for, right? Okay. So do we have a default setup on this one? We have auto set again. Setup recall. I don't know how to hit recall factory because it's way up there. Recall save setup. Recall factory. Ugh, I don't like this idea of just recall factory. Oh wow, so there must be a display setting somewhere because that brightened the display right up. That looks hella good now. Yeah, I think we can even get away with that. Yeah, I think all of my CRTs have a little bit of burn-in done. Am I done moving? I don't know. I mean, all my stuff is moved. I haven't finished unpacking or setting up yet. I only have about half the lab done, which if you guys watched the stream last week, my mom and sister were actually here, and they came and helped me with some of the unpacking and stuff. So that was actually super awesome of them. All right, so let's turn this menu off. Let me get you guys a better view. And then let's see now. So we got output going into channel 1. We're looking at channel 1. This one. So let's change its offset to come up to about here. Uh-oh, this is not encouraging. Oh, probably the same thing. What's our horizontal at? 100 nanoseconds, so we need like 100 microseconds. Yep, did it again. Awesome. Okay, that's looking really good. Also, my initial impression is there's still a little bit of asymmetry. So let's see if we can turn these measurements off for a second because I wanted to make a comment. Okay, there we go. So now we got a nice update going. Good looking signal, right? I think that's pretty good looking. Last time I moved, I still had unpacked boxes from the move before. Yeah, actually, I didn't have that problem this time because I lived in the previous place for almost 5 years, but I have had problems with that in the past. A friend of mine did recommend that any boxes I find a year from now, I should just throw away, because obviously you don't need them. Okay, so okay, that's working. Now let's do a quick check on channel 2 and see if channel 2 works okay. So I'm gonna press, okay, let's go channel 2, and then let's see, where's our trigger menu at? Trigger menu, and I want trigger source to be channel 2. Okay, so if I go back to channel 1, it's not letting me, how do I waveform off? There we go, now we only have channel 2. So, yep, that's looking okay. Let's go ahead and do a measurement on this one. And so let's do measure 1 and select measure 1, and I want the max. Let's go max. Did I hit low? I hit low. Remove, measurement 1, select, max, and min. Yeah, that worked the way I thought it would. So I think that's a little closer than what we were getting with the previous scope, because I think the other scope was like 236 and 250. So I think that's looking a little bit better. Hey Gustavo, yeah, if you want to learn to use a scope, I do have a video on the AddOhms channel on how you can use an Arduino to learn how to use a scope. It was a little bit of a sponsored video because it was the video I made in exchange for Roden Schwartz sending me an oscilloscope. And I should point out, just a bit of trivia, they sent me a scope and spectrum analyzer before I went to work for them. So apparently I did okay on the videos. But anyway, at some point I would like to do a few more like scope tutorials. I don't want to do like a scope basics because that kind of conflicts with my job. But I would like to do a series of like how to make certain measurements because I think that would be helpful. But anyway, let's go back to the scope. If you invert the channel, you can tell if it's skewed. Well, that doesn't, I'm not sure I follow what you mean. I mean, if we, where is the vertical menu? Invert on, because I mean, it's a sine wave, so inverting it doesn't really, I guess I can see a little, oh, let me move out of the way. I can see a little bit of difference, but it's not quite enough. I don't know, does this one have persistence? Vector accumulate, and then infinite. Okay, so now if we go back to inverting, interesting. Okay, I want to turn that off, so I'm going to go back to the display. Let's turn the persistence down. This is just kind of funny. So this is sort of suggesting that the minimum persistence time, so the minimum amount of time that this can display a waveform is 500 milliseconds. Modern scopes can do millions of waveforms per second. So this is telling me it can do like a couple of waveforms per second. And then I don't know if it's coming out very well on camera, but what you'll actually see is you'll actually see the screen update like a few waveforms, and then it pauses for a brief moment, and then it goes back to updating and then pauses. And that happens because we have measurements turned on. And so the overall processing system on the scope is having trouble doing measurements and displaying waveforms at the time, which is typical of early digital scopes. I mean, modern scopes today still have some issues with it, but it's not always as obvious as this one. So I'm not saying that this is bad, by the way. I'm just pointing out another kind of caveat with older digital scopes is their update rate performance and just overall usage can be a little bit sluggish. So, okay, I was gonna do another thought is if we can, does this one support averaging? Main, intensified, delayed, that's time base. I guess it would have been under time base if that supported it. What I'm looking for is waveform averaging, but I don't see that. I don't think it'd be under trigger. It shouldn't be anyway. Yeah. What about under display? No. Acquire. Yeah, that's what I'm looking for. So let's do 16 averages. So what this is going to do is it's going to take multiple acquisitions in a row, average them together, which will increase the effective number of bits, which should give us a much more accurate measurement. Happy little PCBs, good to see you. You're asking, does it get worse with cursors? Let's find out. I'm gonna hit cursor. Let's do vertical bars. I'm on a parallax, so if you're kind of wondering why do I keep hitting the wrong button, it's because I'm looking at it from the side, because otherwise the screen would look like this. And I've been told that you guys don't like it when when you're looking at the back of my head versus whatever it is I'm trying to show you. Okay, so this cursor, the problem, okay, so first off, notice that now that we've done averaging, our measurements are even a little bit closer now. Now they're off by, was that 1 millivolt plus 3, 4 millivolts. So we're about 4 millivolts different between top and bottom. So I'm actually suspecting the generator might have a little bit of an issue, but I think the other scope might actually need a calibration. Okay, so now that we've got the cursors turned on, so I've got cursors on and measurements on, and I'd say the update rate's about the same, which I would sort of suspect because usually the way that these work is the cursors are going to, so especially on older scopes, the cursors are part of the CPU side. So it's all working on the data that's been transferred from the acquisition system. And so once it does measurements, drawing the cursor has no more processing hit as anything else. I never get sent any good stuff. Well, I do have to say the person that the two people that ended up providing me or facilitating me getting the equipment are people that I had worked with for a very long time, and they changed jobs. So it wasn't by random chance. So that's for sure. But yeah, that looks much more centered. Yeah, I'm thinking the other one has a vertical issue. Which is okay, which I'm actually sort of okay with, because part of the reason I bought that other one was because I wanted to demonstrate the undersampling of the scope. That's why I looked it up in the datasheet, because I wanted to make sure it was the one I thought it was. Because I actually think I think this TDS 350, I said it wrong. I said I think I paid $40 or $50 for it. Now I remember, because I actually paid $100 for it at the flea market. I think they were asking $150 and I gave them $100. And part of what I want to do someday is make a buying guide to scopes. And I want to point out, between this digital scope and that digital scope, that they're somewhat similar in bandwidth, and you can buy them today for somewhere similar price, but realize the difference between the two. Like this one has a 1 gigasample ADC. However, it only has like 8K of memory. And so it doesn't take very long. When I say very long, is once you get to longer time bases before this sample rate drops to something really small. But at least if you're looking at a 100 megahertz signal with the scope, it will very well digitize it because it has enough sample rate. It's just that the memory depth is really low, like really, really low. And that's something that you really have to look out for on older digital scopes. Okay, so that's pretty cool. We didn't do this before, but I'm going to do it this time. I'm going to switch this to a square wave. And let's just see what the, what am I looking for? How does this one do it? I guess it does it as a pulse. Okay, and then I'm going to zoom in. So let's change our vertical or horizontal. And I want to get a really good look at that. And I'm going to go to acquire and turn on averaging. And let's give it a second. I think it's already up to 16 averages. And then under measurements, I'm going to turn off everything we have. So I'm going to do remove all. So select measurement. And this time I want to do a rise time measurement, because I want to see something. Okay. So it's saying 32 nanoseconds. And knowing how Tektronix did their filters, 32, -9, oh, that's not right. 32 exponent negative 1, oh, nope, not 1 over, 0.35. 0.35 over the rise time is 10, 11 megahertz, or 11 kilohertz. Okay, so, okay. So this function generator is too slow. What I was trying to do is I want to measure the bandwidth of the scope, and the one way you can do that is if you look at the rise time. So this is supposed to be a 200 megahertz scope, and being an older scope, if you take 0.35 over 200 megahertz, it should have a rise time faster than 1.75 nanoseconds. And so basically, if I had a faster signal, which I think for a moment, oh, actually, an Arduino might work. But basically, if you put a signal in that rises faster than 2 nanoseconds, then the scope will only measure 2 nanoseconds. And so a really good way to tell if you need more scope bandwidth is if your rise time measurement is the same as the maximum rise time that the scope can measure. In this case, we're measuring like 32 nanoseconds, so this signal is well within the bandwidth of the scope. Not all scopes are created equal. That is true. Okay, so I'm pretty happy with this one. We tried out both channels, measurements stuff. This was the one I was the most worried about, because I think of all of my classic scopes, this is the most usable one that I have, and I was really worried that it wasn't going to survive the trip. So I'm glad that it's working as well as it was before. At some point, I need to open this up, recap it, clean it, all that good stuff, and maybe we'll make a video out of that. But that is not what we're doing tonight. Okay, so let's really change gears, and now let's go to an analog scope. All right, so let's get this guy out of the way. I don't know, walking around, pacing around is probably annoying you guys, but I really like being able to move around. One of the hardest parts about doing long live streams has been sitting still for so long. Even normally I do a stand-up desk, and I've been not doing that on stream, and I've been thinking about going to stand-up desk simply because Kit Bogus started to. So that looks, I feel like that's like getting worse every time I move it. So it needs to be somewhere over here. If we do roughly this, then I think we'll be okay, because the only thing you're going to miss is the time-based knob. Okay, so he's plugged in, and I have no idea. Oh, it's already on. Now this one I think actually has a brightness problem, so that could be an issue. Oh crap, it's also cracked. I hope that's just the lens, and maybe it's just a scratch. Okay, so this is not a good sign so far. Does it have a fine beam? Okay, so I'm going to crank the intensity most of the way up. But what I'm looking for is a fine beam button, which will normally put like a dot so that you can actually make sure that the scope is working. Oh man. It's in auto. AC coupling is fine. Vertical. So this is the trigger, channel 1. Channel 1. I don't care about the slope. We're at, let's go 100 millivolts per division. There we go. Okay. Oh, I was getting really nervous there. I was like, oh my God, there's nothing on the screen. What are we going to do? What does the note say? So the notes are, focus is not great, and control switches, I think it says dirty. And basically what it's telling me is like, I can feel it, like when I turn these, they don't have satisfying detents. They don't click. So, yeah, so want to get that cleaned up at some point. So notice how this waveform is actually doing this. It's like it starts down here and it comes up here and it's slanted. So that's actually the astigmatism. I don't know if that's the right word. That's what I say, astigmatism. Let me grab a where's my tools at? Oh, so funny. Let's see if we can straighten this beam up. So we'll grab this and then, oh, no, this one. I'm sure I'm supposed to use like something that's plastic, but I don't feel like looking for a thing like that right now. Okay, so that is not the control I thought it was. That's what I wanted to change. Okay. I think that's much better. So we'll go with that. Why not? We'll go with that, why not? Man, I need to learn how to do a Zoidberg voice. Okay, so now we're ready to finally put a signal in. Okay, I'm going to try to do the same thing I did before where I route this around here, up through here, just to kind of keep things nice and clean. Get that out of the way. Plug that in, turn this on, turn on output. Okay. The scope needs glasses. The cursor moving. None of your tools have a place yet. Yeah, what's really frustrating is the lab's only halfway set up. Hopefully Monday, the new benches will arrive. And so I'll get those set up. And then once the benches are set up, then like I'm pretty sure with the new configuration, I'll have like a pegboard so that we can actually have some of these tools be in a constant place. And then eventually when I get this guy moved where it's going to actually stay, then on that wall over there, I'll actually have some more pegboard. But I don't want to do that until I get this moved over because there's an issue on that wall that I got to take care of. So, hey, Amateur Radio, thanks for the raid. Man, I tried to send some people your way the other day, and I think I looked to see if you were streaming, and then by the time I got the raid going, I think you had actually stopped. So welcome everybody. My name is James. I'm the Bald Engineer. In this live stream, I am actually going through a bunch of oscilloscopes that I have. They're my older scopes. I just recently moved halfway across the United States. And so I'm just going through them to see that are they all working. So we've already gone through 2 digital scopes and now we're looking at an analog scope. And this is the first analog that we're looking at. And so we're going to check it out, see how it's working. So we'll see how it goes. Yeah, no worries on that. I just I thought it was hilarious because sometimes, like the other night, I was really tired, and so I said, "Hey, let the streamer know that I'm sending you guys because I'm not gonna join." And then I got a text message from one of my friends saying, "You realize he just stopped, right?" I'm like, no. Okay, so let's go to this guy. So we've got our output going into channel 1. 100 millivolts per division sounds good, but we're going to need 100. Let's change our vertical. That is not the vertical. I don't know why I thought it was. Let's go. Uh-oh. We should be. I'm still at a kilohertz, so 50 microseconds should have been enough. AC coupling is fine. Duh. So, so right now on the channel 1, I told it to go to ground so that we could actually find the trace. And so now I need a DC or AC couple it. So if I AC couple it, it removes any DC offset. If we put it to DC, then we will see any DC offset. And so since we already know that we might have a little bit of a DC offset issue with the generator, I want to make sure I leave it in DC so that we can continue to see it. Now we're going to, there we go. So now I'm changing my sweep time, and then let's see, can't really see the trigger level. Now, oh, where did it go? Where did it go? Get it up to about here. That's going too far. Nope, come on. Why are you having such a hard time triggering on it? What did I do that changed its ability to trigger? Is there a delay? I wonder if there's a delay dialed in. That feels about halfway. And then that's not doing it. So AC couple's fine here. We want channel 1. Let's go to normal, see if that helps. That's weird that it's weird that there's so much jitter on it. I think we're gonna try, and also it's weird, why am I getting a square wave? Oh, because we did square wave on the last one. I forgot to change it to sine. That's why. Okay. Okay, let's just try something. I'm gonna change the frequency to 1 megahertz. And I wanna see if we get a more stable, interesting. I wonder if there's a stability issue or what's going on. Okay, so let's go back to a kilohertz because I want to make a point about the difference between an analog and digital scope. 1 kilohertz. Okay. Huh. I'm still surprised it's jittering as much as it is. So one of the interesting things about an analog scope is the trigger, or the difference between, a major difference between analog and digital scopes is the concept of trigger. So in an analog scope, trigger is effectively the time at which the beam starts to trace across the screen. And the idea in an analog scope is as the beam traces across the screen, the voltage on the input will move that beam up and down, and so that's how we end up seeing the signal that we're seeing. In a digital scope, triggers don't have any effect on when the acquisition starts, or really even when it stops. A trigger in a digital scope simply identifies when an analog event occurs and tags the digital sample where that analog event occurred. And so it's almost more correct to say that in an analog scope, a trigger actually starts the acquisition, and in a digital scope, in a way, the trigger stops the acquisition. But a big difference between the two is the analog scope, there is always going to be a rearm time on how long it takes for the beam to come back and sweep to the other side. And then the rate at which it moves across the screen is a function of the time base, which means it's a function of the input signal. So because we're putting in a 100 or 1 kilohertz signal, we have to sweep for 100 microseconds to get a full cycle on screen. And so it fundamentally limits how fast that the analog scope can paint a picture on screen. And so that's why the 1 kilohertz signal is dimmer than the, say, 1 megahertz signal, because the scope can't re-trigger until it gets to the end of the screen and then comes back around. So just wanted to point that out. Oh, thanks guys. Yeah, I need to figure out something better with chat because you caught the ground way before I did. So that was my bad. Now, okay, this is another thing. Let me see if I can, because what you guys are seeing isn't quite the same as what I'm seeing. Let me see if I can get the refresh rate to be about. Yeah, because it's actually not flickering on mine, but I'm not sure if you can see it, but it's actually, oh, too far. It's actually like, there's a little bit of jitter, and I'm thinking that's the time base on the scope, is causing it to jitter a little bit. Yeah, so, okay. Now, fun fact, how do we make a measurement on an analog scope? Stop that. Part of the problem with most analog scopes is they can't make measurements. Now, there are some what I'll call late model, especially like Tech. And when I was in school, we had a scope from Philips that can do measurements. In fact, I think my 7704 can do some measurements on the waveform. But this particular scope has no ability to do measurements. The only way to do measurements is with the graticule. And so that's not terrible. It's better than nothing, but it does make the scope a little bit more difficult to use because you actually have to do some work to make a measurement. It also limits the accuracy because you're down to the accuracy of the beam and the grid and your eyes. That said, there's a couple of things, and we've already sort of ran into it, but I did want to point out when you're using an analog scope, a few things that will catch people. So make sure that your vertical mode, if you're looking at one channel, is set to the channel you're looking at. Alt and chop are a way to look at two channels at the same time. Vertical mode will typically be separate from the trigger source. Just like on the digital scopes, you have to tell the scope which source do you want to use the trigger. So commonly on analog scopes, you'll see a line. That means it actually uses the 60 Hertz cycle to trigger. For most stuff you do with a scope, unless you're looking at AC mains or something that comes off of AC mains, like through a transformer, that won't do you much good. But make sure you get the source. Like in this case, vertical, and I'm almost positive that in this case, it's saying the source is vertical, which should be the vertical mode. Not 100% sure what vertical means, but I'm pretty sure that's what it means. Trigger level. This is actually, for me, I find this kind of frustrating on a analog scope. It's hard to tell, but I'm pretty sure that means my trigger level is roughly 0 volts right now. But this scope has no visual indication on what's going on with the trigger level, and that always kind of bugs me. I'm so used to it from digital scopes that when I don't see it on a scope, it's hard for my brain to see it. Now, on the knobs, if you look closely, there's actually a large knob and a small knob. And so, this one is not doing so well. What I was going to say is normally what happens is you're stuck to divide by tens or 1, 2, I'm sorry, not tens, 1, 2, 5 steps on the big knob. And then the small knob will be vernier, but either my potentiometers are bad or this thing really needs to be cleaned because that doesn't look very good. So that's the difference between these two. Over here on the time base, something to know is not all analog scopes do this. This one does. It has a divide by 10 or a multiply by 10. So right now we're dialed into 20 or 2 milliseconds per division, which I think actually, so times 10 means it should be 20 milliseconds per division. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be 200 milliseconds. Is that? I think I said earlier, I said the number wrong. 200 milliseconds or 20 milliseconds. What am I doing? What in the world? 20 milliseconds. I'm not sure I believe that. Oh, that's because that's not what I'm doing. Yeah, it is. Yeah, I don't know if I believe that. So anyway, normally you would say the sweep time, which is basically, this should be saying that this is 2 milliseconds per division. There's 10 horizontal divisions. And then by 10, if it was 2 milliseconds divided by 10, that would be 200 microseconds, which is actually, yeah, okay. So this is saying it's at 2 milliseconds per division times 10 actually makes it 200 microseconds per division, which makes more sense to me because a 1 kilohertz signal is a millisecond. What? Wait a minute. I've got this totally backwards. Yeah, okay. I did this backwards. So right now, this is times 10. And then when I put it in, now it's regular because it's 2 milliseconds per division. Each cycle takes 1 millisecond. Okay. Yeah, I can do math. Really, I can. The advantage that this has, I think, is then it sweeps faster, so that's why we get a brighter display. How do you make a measurement? With a ruler. Yeah, no kidding. Yeah, so so that's just a couple things. At some point, I actually would like to do a little bit of a video on analog scopes. I actually had put it in my mind that I would never do a video on analog. And the more I got to thinking about it, it's like, you know, every once in a while, you're going to go into a lab and use a scope, and you're going to have something like this cheap Kenwood, which I shouldn't say cheap, this inexpensive Kenwood. But I mean, in terms of its analog bandwidth is 20 megahertz. It's 2 channels. Even though it doesn't do automated measurements, outside of that, it's a pretty good scope. So like if you're doing, I would say like up to Arduino type circuits, I mean, you're not going to get a digital output from Arduino that's faster than 20 megahertz. So that's a pretty decent scope. The only caveat is the switching speed on an Arduino is much faster than what this scope can measure. So like if we were to try to make a rise time measurement, it would be wrong because we wouldn't see all the signal content because the signal is too fast. But anyway, where I was going to go is I would still like to eventually talk a little bit about how to use an analog scope. Frankly, one of the reasons I haven't done it is because, as you can see, I'm kind of struggling to use it right now is because I have to think about how it works since I don't use one every day. How to diagnose and fix everything electronic is a Bible on analog scopes. Well, that is very cool. Yeah, I first learned on an analog scope. I'd like to get one, but I have no idea what to actually use it for. I mean, frankly, what I want to do with my analog scopes is use them as, I think GB was talking about earlier, I want to use them as a clock or that scope metrics, or I want to use it as a analog vector display. I don't really want to use it as a measurement. This is, by the way, if somebody with a gray beard and suspenders tells you, well, analog scopes are better than digital scopes because of blind time, blah, blah, blah. Okay, they don't know what they're talking about. It is true, 20 years ago, just like I was talking about how on the other 2 digital scopes, there were some significant trade-offs in the fact that they were digital. One had a really slow sample rate, the other had a really shallow memory depth. And they got slow when you turn on measurements and stuff. So without a doubt, that has been an issue with digital scopes. Today, I would be hard-pressed to give you a single advantage that an analog scope has over a digital scope. Because modern digital scopes, even the cheap $350 to $500 scopes that you can buy, are really decent digital scopes. 10 years ago, questionable. 20 years ago, there were still advantages to an analog scope, but today I can't see one. The only exception I have to that is if you're going to buy a used scope, a analog scope has a much higher likelihood of being repairable versus a digital scope. Analog scopes still have custom components inside, but most of them have a schematic available, so that increases the chance you can actually troubleshoot it. Many of the components are off the shelf or have off the shelf equivalents, but you know, like especially like I have an old Tech 465 that doesn't work. Its vertical amplifier is a custom chip from Tech, so if the vertical amplifier is blown, then I have to get another Tech 465. But if, say, a transistor in the power supply blows, that's not a big deal. Or even a transistor in the signal path blows, I could probably find a modern equivalent. Whereas on a digital scope, you know, there's only a couple of chips in there. There's going to be the front-end attenuator stage, the amplifier, the ADC, the memory controller, and the processor. And if any one of those 5 chips blows, you're not going to find a replacement. There's no such thing as a oscilloscope front-end module on DigiKey. So just keep that one in mind, is that one benefit if you're buying used is an analog scope has a much more likelihood of being repairable than a digital scope. Okay. Yeah, in TC Evans, intensity grading on digital scopes eliminates the last advantage. Then that's really what I'm getting at. Like if I look at a modern scope, and of course, well, even outside of who I work for, modern digital scopes, not only do they have intensity grading, but they're able to re-trigger so fast that they can usually trigger faster than the display updates. And so you also get intensity grading that you wouldn't have gotten on an analog scope. So just like we're seeing here where different time bases have different intensity levels, a digital scope, it's able to re-trigger hundreds of thousands of times per second. And so even though the display only updates every 60 times a second, you end up getting persistence through even that. And so the one thing the analog had for a while was intensity grading, and now digital scopes do it even better than what analog can do. So yeah, that said, and I want to be careful, because if you come across a really nice analog scope and all of its channels work, and even if the channels are off a little bit, so like the other scope, the other digital scope where it's not symmetric, even on an analog scope, if it's off a little bit, there's probably an adjustment you can make to fix that. Or, you know, if I don't remember what I paid for this scope, but if somebody was selling this 20 megahertz analog scope in the $20 to $25 range, and I had no scope, I would rather have this for 25 bucks than nothing. Now, I wouldn't pay for a 20 megahertz analog scope. $25 is probably about what I would pay. $50 maybe if it did analog, or if it did automated measurements, and if it came with probes. But $25 to $50 is that I would be like, depends on how clean it is. Over $50, no way. Yeah, okay, let me move on. Okay, so we did this analog scope. Let's go back to a digital scope now. I feel like I had another analog. I guess the only other one I have is the Tech 465, but it didn't work before I moved, and the movers broke one of the knobs. So I know it's not going to work now. There's no point in testing it. And then I have the 7704, which maybe we'll just save that for last, because that is actually, after I just said a bunch of crap about analog scopes, it is my favorite analog scope. All right, get this guy out of the way. And then, now this one's a little bit different only because it is a logic analyzer and an oscilloscope. And so it's going to be a little more interesting to work with, I think. So let's go something like this. Let's move this guy up here. Okay, zoom in just a tad. Oh, see how pretty, see, I can make scopes look so pretty. That's a skill, I guess. I could put that on the resume, right? All right, I did all that, and now it's not going to turn on. This one requires an IEC cord, which I see it. Where's the, oh, it went down there. Plug that in. So we're not going to play with it today because I don't want to get into it. But so this is actually a logic analyzer that has a scope capability, and so it's really meant to say trigger on digital channels and then show you an analog waveform with the analog channels, which is sort of the opposite of almost every oscilloscope today. So every oscilloscope today is what's called an MSO, or mixed signal scope. Because, oh, I'm missing a foot. Oh. Well, let's take this one off so it stops rocking back and forth. And we'll do that, and then the other scene should be just fine. But anyway, so like most modern digital scopes have the analog channels plus some logic channels, but it's primarily an analog, or primarily meant for analog measurements. So this one is the exact opposite. It's really a logic analyzer that also has some analog capability. Let's turn this on. see what happens. And I think this is running like HPUX or something, so we'll have to see. I love the 465, I have too. Yeah, I wish mine wasn't busted. Yeah, so these did have floppy drives. I don't remember if this came with it or not. It might be one of my own. Actually, I'm almost positive this didn't come with it because it's a HD. But we'll give it a try. We'll see. Okay. So let's see. I turn this off. Yeah, we'll turn that off so that we don't get the glare. Okay, so black and white. Now, as I was saying, so the way this one works is it's actually a, let me think. It's got 1, 2, 3, 4. So it has 6 digital pods, which can then be configured into multiple machines. And really? Oh, okay. So I'm thinking of like my HP 500, which has a touch screen. So I have to use the cursors like a animal, which stopped working now. Okay. Okay, so that's helpful. So 102 channels. Really? Because these pods are, I thought these were 16 channels. So what would be 16 times 6? 60, 72. Yeah, 96. So they're actually, and I take that back, these were 34 channels, right? 34, 6. Ugh. 16 times 6 is 96. But then there is a clock on each. So 6 plus, that's a 102. Okay. Okay, so each pod is 16 channels, and then each pod also has a clock. There's 6 pods, so that's how they get to 102. And then it samples at 500 megasamples, or these are unique compared to like a Tektronix analyzer because the clock input actually makes it state, which means it samples like a state analyzer. Anyway, you should use that quote on a t-shirt. You'll have to tell me which the quote was. You wanted to get a 1670 or a 16700 because the 16700 is what I used for almost a decade. I learned to really dislike that machine. Okay, so long story short, so it has the digital channels, and then there's also the 2 channels of the single shot oscilloscope. Single shot is a really good indicator because what this is telling me is it samples at 1 gigasamples per second, and unlike the other one the other digital scope we're using, it doesn't require repetitive signals, which is good because the logic analyzer tends to be pretty slow in terms of trigger. So, okay. Now okay, that's not what I want. Let's go to config, analyzer 1, configuration, machine, analyzer 2. So what I want to do, I think, is let's go into here, and then let's go machine 1. So it's showing that there's no activity, which isn't a surprise because I don't have anything connected. But I'm not remembering how to, let's go to the system. Nope, config. Trying to remember how to actually, so, okay, so let's go ahead and do a single run. And then what I'm ultimately looking for here is I'm trying to figure out where you turn on the scope channel. Because, if we just go to waveform. Okay. So turn on state analyzer. Oh, so it has to be in state mode. Was not expecting that. Plot twist. So now go to waveform. Ooh. Waveform, mixed display. Wonder what they mean by count time. I don't remember that at any point. Let's try acquisition control, automatic. Yeah, okay, that's not doing, oh, here it is, count time. Okay. Waveform, select. I guess mixed is what I'm really after here. Time correlation of data is not possible. Okay, that's not helpful. Slower missing clock. Oh, because we're in state mode. I don't have anything to hook up. I don't have a, are there pods in here? No. There's a termination adapter. That's not going to do me any good. Oh. I do have flying leads somewhere. I just don't remember where. Oh, I have to use cursors like an animal. All right. Actually, that'd be fun to wear at work. All right, so stop. So maybe this one, I thought we could put this into like, this isn't going to work the way I thought it would. I thought I was going to be able to put this into, that's what I want, configure scope channel. Can I just run the scope channel? Okay. And then we can go repetitive. Okay, now we're getting somewhere. What we're not going to be able to do, I think, is get scope and logic at the same time, because at the moment, I don't really have a good thing to hook up. I got to see if I can find my MSO board, but then I don't have a power supply yet. Okay, so let's turn this guy on, turn its output on. So time per division, let's go to 2 milliseconds. Okay, so we got to change its offset. Done. Do we have to stop it? And then I can go and change. Oh man, this is painful. Volts per division, that's not what I want. Let's change the offset. Can I just dial in 0? I go to the big screen so you guys can see what I'm doing on the control panel. So 0 volts. Let's go, that's space. Clear entry, don't care. Sounds funny, but that's when you're entering a trigger if you want it high, low, or don't care. I guess done. So 0 volt offset, let's do run. Okay, I didn't realize there was a run button, that helps. Let's do 400 millivolts per division, run. Oh, nope, 2 volts per division, run. And then I can do, so it says run, and then it has a blue for repetitive, so we can tell it to go run repetitive. And then just for fun, what I'll do is on the frequency generator, I'm going to go into the frequency and just start increasing it so we can actually see the waveform change. So that's kind of cool. Okay. Not familiar with the 1660. Yeah, so I mean, like I said earlier, the 1660 is really a logic analyzer that also happen to have scope channels built into it. So it's really not meant to be used as a standalone scope like we're doing right now. What normally would happen is you would hook up one of these digital pods. So you'd hook up one of these pods. There's like, I have an adapter that turns these into flying leads. So we could hook this up to say like, just as an example, like an Arduino circuit, and then we could probe something with one of the analog channels. And ideally, and what I was trying to get to earlier was I wanted to show that you can have the digital waveform and the true analog waveform next to each other. And that's really how this scope was meant to be used, is it was meant to be used as a way to correlate analog activity with the digital activity, which is why I say it's like literally the exact opposite of today's digital scopes, where there's 4 analog channels and then like 16 or 32 digital channels. And there you're trying to correlate a digital activity to the analog. So it's just interesting to me that back in the 90s, this was the popular instrument, and today it's the exact opposite. So, yep, yeah, I mean, it's a reverse MSO. It's so, which is really cool. I mean, don't get me wrong, it's a really cool instrument. And what's funny is, what's interesting to me is like the 1660, I didn't use these very often at all. But they have a very similar operating system to the 16500, which is why it's driving me crazy there isn't a touchscreen. And then 16700, so I said this wrong, these have some form of embedded operating system that's actually in ROM. And then starting with the 500, maybe, definitely with the 700, it went to a traditional operating system with a hard drive. So, but the UIs were all sort of based on the same things. I was just looking at the back and wondering what ports it has. It has a LAN port. I wonder if I can control it with Skippy commands. That would be, I wonder if there's a Visa driver for it. That would be pretty cool. Okay, let's stop that, and then I want to see, so I know it's behind chat, but let's put this floppy drive in, or floppy disk in, and see if it'll read it. So select, let's go to disk. Oh, no way. Oh my God, I've even used it before. There's a file called Baldy. That's too funny. I wonder if it'll load it. I don't think it'll load it, but let's try. Will it load the TIFF file? Yeah, I just don't think it, oh, I see. So you say, I want to load all data. Normally you would tell it if you don't want to load all of the, like the waveform data, the file execute. Yeah, it's looking for a configuration, so it won't load that one. But that's disappointing. So I will at least do this. Let's see, can we do, let me, I was hoping it would, I wanted to reread the disk. I don't know how to get it to, maybe if we go to config and then come back to system. Yeah, okay. I was trying to get some good disk noises in there. Thought that'd be fun. Back then, LAs were a big deal. Yep. Yeah, Circadian, I'm totally with you on that one. I mean, it's, they, LAN port is likely for a web interface. So on the 16700s, they had a web interface. They actually used VNC because they're just running HPUX. They probably don't have any form of built-in like web interface because when this was built, web browsers were not all that common. But it probably could use, if we look at the utilities, it probably could, like, it might have like an FTP server or something like that that we could access. Let's see. Let's go to utilities and then, okay, well, it's Y2K compliant. It knows that today is June 12th. That's pretty cool. Luminosity, shades, okay. I don't see, I wonder. HPIB, yeah, that's not, oh, no, that's not what I meant to hit. I meant to hit system, HPIB, select, controller, printer, okay. That's weird, it only supports HP printers, I wonder why. Huh. Okay. I wonder if the LAN port even does anything on this one. There's a really good chance it doesn't. Oh, It's going to try to load the system test from the disk. That's not going to work. Okay. I guess it means it passed self-test. I don't even know. I don't know what just happened. Okay. All right. HPIB over Ethernet, possibly. I take it back. Totally take that back. It is not a LAN port. It's a keyboard port. I remember now. These old HPs had like it looks like RJ45, but it's a little bit different. It's a little bit fatter, and it's for a keyboard. That's what that's for. Which would be why there's nothing in the UI about it. So, okay, cool. Can't really test a logic analyzer, and I didn't really want to do logic analyzers tonight, but we should totally do that. Like, it would be kind of cool to do a video to compare like a legit logic analyzer to an oscilloscope. And it looks like this one passes self-test. My 16500 doesn't, so we couldn't really use that one because it's not really usable anymore. So hopefully one day I come across some new acquisition cards for it. Okay, so let's turn this back on. Let's get this guy put away, and then we're gonna get out the big guns. Or the big gun, I should say. I've already done a stream on the 7704, but I figured, what the heck? Let's do one more. Okay, get this guy. Whoa, 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 whoa. So that's why you shouldn't drink while you do this stuff. Huh. Oh, man. Okie dokie. You know, sometimes when I say things on stream, I wonder if there'll be a clip. I feel like that's going to be a clip. Just saying. Just saying. Fortunately, that's all that. Oh, that's the foot. I need to do something with this foot. Why didn't that close? What's holding it up? I don't see anything getting in the way. Okay, one more time. Let's try that again. Okay, big guy. Here we go. Yeah. Now this is some vintage scope right here. Oh, is this not the one that's reflecting? It is, but, oh, come on. That is weird. The angle doesn't seem to matter. Okay, well, this has too many cool things on it. We need to be able to see. Oh, there we go. Perfect. That'll work. And maybe if I do a little brighter, then we can see a little better. Awesome, 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 awesome. Okay, dokie. So this is my Tech 7704. Let me make sure. So that's okay. Like I said, I'm a little bit concerned about this one having a magic smoke event. The thing about this scope is it's modular. So like this is the trigger module. And then this is the time-based module. Okay. This is a differential channel input. So there's like a plus and minus. So I think this is 100 megahertz too, if I remember. I might have that bandwidth wrong, but I'll tell you a story about that in just a second. There we go. And then this is just a traditional 2-channel analog input. Okay. So what's really cool to me, I think this is really cool about the scope is if you look carefully, there's this section and then this section, and then there's like this intermediate. And if I turn the scope just a little bit, notice that there's this section and then there's a gap and then the rest. And then right here is a separator bar. And what's really neat is if you take this bar and the other side off, then this whole top half and this whole bottom half come apart. And so this is truly a modular system. And earlier I said when Tech got into the DPO series or the DPO scopes, the digital phosphor oscilloscope, that's sort of when they started to really take hold in the digital market for about 20, maybe 30 years. But what was cool is there is a module for this scope, which is the digital phosphor storage unit, which goes between the two modules. It goes like in between the two, and it adds digital storage capability. And so this scope has the ability to also become a digital scope, which is super cool. So here's my story about this one. And I've told this story before, so if you've heard it, I apologize. But back when I worked, nope, there we go. Oh, that looks terrible. We're not gonna do that. I don't like seeing how fat I am. Back when I lived in the Bay Area, so this was last fall, I was going to the electronics flea market. And when I was at the flea market, one of the things I always looked for was old test equipment, which is what some of this equipment actually came from. And so I saw this sitting on a Tektronix cart, and I had been thinking about a tech cart because those are super popular and they can be expensive. But at the time, I had like less than 20% of the space I have right now. And so there was nowhere I could put this tech cart. So I was really looking at this scope, and the guy had a price tag of $150 on it. And I was like, well, I could probably offer him 80 and get it for 100. And while I'm looking at it, the guy comes over and he just says, yeah, you know what? If you like it, I'll give it to you for 100. I'm like, okay, let me think about it for a minute because I'm not sure if I want to carry it back to my car. And then I kind of walked away, and as I was walking away, I was like, I don't know. I guess I could drive my car around and then I won't have to carry it as far. And so I started to walk back to the guy and I just said, okay, well, it doesn't work. He said, well, that's the thing. It turns on, but there's no trace on screen. I was like, oh. So $100 for a broken scope that I have to carry back to my car. And then this guy walks up and he goes, excuse me, this differential module, how much do you want for that? And so I went, okay, I'll take it. And gave the guy the $100. And the guy, again, the second customer again, I think I could probably give you like $250. And the guy goes, sorry, I just sold it. And I'm like, wow. So I did look it up on eBay, and that module typically can go for like $200 or so. And so I just kind of laughed because it was sort of one of those things where until I saw somebody else interested in it, I was really hemming and hawing. But when the guy pointed to the module, and I didn't even notice it until he said it, that it was a differential module. But when he pointed to that module and was like, how much do you want just for that? I was like, okay, that module is going to be worth at least $100. So I got it home. The trace didn't work. Like the CRT didn't do anything. I took it apart, figured out that there's like a 1 mega ohm resistor in the CRT path that burned up for some reason. I replaced it. Cost me $1. It cost me $2.15 because I had to go to Fry's and buy a package of 1 mega ohm resistors, and it started to work. So let's see if it made the move, because I just feel like this beast may not have survived. Okay, that's always scary to hear the, okay. Shit. I don't like the trace to be so high. Okay, so let's go vertical mode. I want just the left module. For trigger, I want it to be the A module, right? I think that's what I want. And then on here, let's go to ground. Let's put ground and ground. On here, I think we have to set the mode. So let me get in the way for a second. I want display mode. So one knob control, and I don't know which one is it? It's 2. So I want the trigger to be channel 1 and the source is A. So that's how we set the trigger. And then display mode, I want it to be channel 1. It's on alt right now. Okay, it's still stuck. Vertical mode, left vertical. Delaying time base, okay. Oh, that's what it's saying. So trigger source could be A or B. Right now we're using A, which is the delayed time base. I think I actually want B, because I'm not very good with the delayed time base. Yeah, okay, I do want B. And then we're gonna want 2 milliseconds per division. Maybe divide by 1. Or by 10. Okay, let's get a signal in there and then we can figure out more what's going on. But at least it turns on, so that's awesome. Whoa. Yeah. What I was worried about is on analog scopes, you really have to be careful that if the trace gets too bright, you can actually either burn the phosphor, well, you can burn up the phosphor. And so it always makes me nervous when I should have turned the intensities down before I turned on the scope, and I didn't. So, okay, let's turn this guy on. And let's go back to frequency 1 kilohertz. Turn on our output. Okay, so we were out of focus a little bit. So 20 microseconds, okay. And then we should be, what were we using for voltages before? Like 200 millivolts per division? Got to go to DC, and I can totally tell now. So if we go divide by 10, there we go. And then I think we've got a delay going on. Let's turn that intensity down. It's really worrying me. Slope level position, there we go. Now we're right on the middle. 1 volt, and then let's see, this is the position knob. That should be vernier right there. Oh yeah, oh, so satisfying. Okay, so this guy's working pretty well. And then we can change our readout, and then let's change focus a little bit. So, okay, good times. So this scope can't do measurements either, but it does add a text generator, and so it tells us what our volts per division and our time base settings are. And so super simple thing, but oh my gosh, it's so nice to have. And then you probably can't tell, but there's like a groove around, like up here, there's a groove. And then over here are there's actually electrical contacts. And the idea is that you could put a camera adapter on this, and then I think these will actually even trigger the certain cameras. And so the whole point, like the whole thing about this screen is it was designed so that you could get really good screenshots, literal screenshots from it. And that was part of the reason why they added the text generators. But I'm super happy. That's looking really good. That's actually working. I'm excited about that. Great headshot. Thanks, guys. Oh, yes, this deserves a yay.
And there was much rejoicing.
Cheers. Okay, that's awesome. So I'm so happy about that. I was really worried that this scope wasn't going to make it. I think that shows it is doing well. Hands up if you're still seeing data sheets with analog captures. Yeah. Yeah, actually, if you go look at I think that There's some op amps that I was looking at recently for the op amp circuit we used to be working on, which we got to get back to here pretty soon. But yeah, there were some op amps I was looking at that from Burr Brown that were they were analog scope screenshots. Cracked me up. It's like, wow, that's been around for a while. Okay, so I wish this was a dual output because then we could actually play around with the differential, but I would have to go find my dual output for us to do that, which I may not do tonight. Man, it's only been 2 hours. Man, it feels so much longer. I feel like we accomplished so much because we checked out 1, 2, 3, 4, 5 different scopes. Yeah, that's awesome. Yeah, this is my favorite scope, my favorite analog scope, by far. I do sort of want to hook up. I do, because I've never hooked anything up to the differential module, and so what we can do is I've got a dual output function generator, and so we could use that to generate a plus and minus. So why don't we do that? Yeah, the box should be down here. So I tell you what, let me do this. Let me go to the bathroom, grab another drink, and then I'll get the box with my other function generator in it, and then we'll play around and see if we can't make the differential inputs work. How's that sound? Good plan? Yeah. Dr. J, you found an an Amiga technical book with like probe points. I might be interested in that. Yeah, okay. So let me do this. Let me throw you guys over to trivia, which I noticed almost every question at the beginning were the ones I put in the other day, so we must be running out of questions. Yeah, so AJ, I'm going to we're gonna test out the differential module on this scope, but after I take a quick break and get a different function generator. So let me do that. Let me throw in the trivia, and I'll be back in just a couple minutes. All right, get this out. It's gonna fit. Darn. Okay, I need a shelf. So let's get this guy out of here. Yep, that's what I'm looking for. RJ, I saw your comment about don't get charged up. Yeah. All right. Got that. Just get that out of the way for now. Don't need that either. Probably move these over here. Okay, so let's unplug the old generator, plug in the new one. So this one has dual output. I don't know that how well they're in phase with each other, but we will use the first module to see that, and then the second module we'll use to do a differential measurement. Okay. Okay. Need another BNC cable. Ooh, did not think this through. Ooh, I thought I brought two down with me. Oh man, if I were a BNC cable in a sea of boxes, where would I be? On my other desk. That's where. Okay. So one thing we're gonna have to make sure is, are these the same length? Okay, turn that on. Did that turn on? Yeah. So let's see. These two look like they're gonna be the same. Let's check this. Yeah, that's close enough. The engineering toolbox, aka the junk box. Yeah, I like to call mine the bit bucket, just because I'm such a digital guy. Okay, so let's do channel 1. We'll throw that into channel 1 on the scope. Let me show you what I'm doing. And then this one will come over here. And then you guys can't really see it, but I'll give you a quick shot of this. So I've got my other function generator. I'll try and move this over so that doesn't look so janky. Okay. So let's go to sine wave on channel 1. Let's do 1. Let's do a megahertz because I want to go a little bit faster. And then on, how do I change the channel 2? Channel 2, we'll also do 1 megahertz. And then for amplitude, let's keep it 1 volt peak to peak. 1 volt peak to peak. I think I was doing 500 millivolts peak to peak before, but that's okay. Okay, turn on channel 1 and 2. So, yep, kind of expected that. There we go. Turn our intensity up now. Maybe go one more click. Well, we'll keep it there because what I want to do now is we're going to turn on, let's change our trigger position. There we go. Now I'm going to now we want to do channel 2, which means we need to either alternate or chop. And, go to DC on him, move the position sort of about there. Okay. Interesting. They're not the same amplitude out. Or do I have like a by 10 turned on? Huh. So channel 1 amplitude, channel 2 amplitude, offset is 0, channel 2 amplitude, offset is 0. Interesting. Because that's 1 volt per division. That's 1 volt per division. They really do look like they're off by a little bit, don't they? I wonder. Let's swap these and see if they look the same. No. So it looks like channel 2 on this has, wait. So right now, so channel 1 is really small, and so, wait, and so they're both at 500 millivolts per division. So now I'm going to only have channel 1 display, and I see 2 divisions. So now I'm going to put this in here, 1, 2, 3, 4 divisions. I think my generator's not working right. That's why. Load. Okay. Yeah, they're still off. That's still not right. Channel 1, normal. High Z. Channel utility. Channel 1, high Z. Channel 2, high Z. They should be closer than that. Unless that changed. That did. 1 volt peak to peak. Okay, there we go. So the generator was set to 50 ohms on channel 1 and 1 mega ohm or high impedance on channel 2, which actually just changes the output. the impedance actually doesn't matter, but that's why it was. So by changing it back to 1 mega ohm, the generator automatically changed its output to display 2 volts per division, or 2 volts peak to peak, which is what it was doing. So okay, so now what we need to do is change the, let's go to channel 2 and change its phase by 90 degrees. Oh, right? Nope, how about 180 degrees? Silly. There we go. That's the kind of thing I'm looking for. Okay. And then we can move this down to like about here. Nope, I want to move that to about there. And we can move this one. Yeah, look at that. Oh, so pretty, so pretty, so pretty. Okay, so the idea is these are complements of each other. And so if we were to take, so let's just say for the moment, that's 1 volt and that's negative 1 volt. If we add those together, we'll get 2 volts, right? That's the idea behind a differential channel, is we take the one channel and subtract it from the other. That's super helpful in digital signals, because if there's noise on both channels, then they'll actually, it'll actually get subtracted out by the receiver. So now we're going to move this over to the negative. Hold on. This has up to 200 volt input. Okay. So we need to tell it to use the right module. I still want to trigger with B. And then my volts per division here. We move this up. And then, no. Do we have to change the trigger level? I don't think so. That's the slope. I'm on B, or on the right module. Oh my, that's going to be an issue. We can actually change the high frequency 3 dB point and the low frequency 3 dB point. And so the low frequency is set to DC, right? Yep, DC. But the high frequency is only set to a megahertz. And we're putting out 1 megahertz, which might be a problem. So let's change our frequency to 100 kilohertz. And channel, go to the other channel. Okay. Yeah, it's still not locking it. Oh my goodness, did it again. I don't know why offset would matter. I can see a pattern. So 100 kilohertz is what? Them clicky noises. Yeah. And they're only going to get better when I finally get around to cleaning the contacts. So what did I come up with? A microsecond? That's where we're at. Yeah, 1 microsecond per division. So we should have a signal at this point. And I sort of see it trying really hard, but I don't know why it's not. Did I mess up something? I want right vertical, and I want the vertical mode right. That should be the same. Okay, that should be right. Oh my God. Oh, it didn't work.
And there was much rejoicing.
Oh, so I had the trigger mode set to be the left vertical instead of vertical mode. And so I had it on left vertical so that when I switched the vertical mode to right, the trigger was still set for left. If I had it on vertical or right, then it would have worked fine. So, okay, so there we go. Okay, now that we've done all of that, so I see 1, 2, 3, 4 divisions at 400 millivolts per division. So that's 2 volts peak to peak, which each output on the generator is 1 volt peak to peak. So we're getting our differential subtraction of 1 minus 1 and yeah. So we're actually getting a differential output. So cool. All right. You mean the cable itself doesn't have much resistance? So just in case, Roy, I don't know if you're asking me or if you're asking in chat, but so practically all cables, so all like this BNC cable has a characteristic impedance of 50 ohms. And so what that really means is if you were to take a piece of it and measure it across frequency, it should be roughly 50, its impedance should be roughly 50 ohms. Its resistance will be practically zero because it's just wire. But between the wire and the jacket, when you put an AC signal into it, it will appear to be a 50 ohm load. So its impedance is 50 ohms, not its resistance. And so the generator doesn't know what its output impedance is going to be. It doesn't know the impedance that it's driving. And so if you tell it that it's driving a 50 ohm impedance, which this scope is not, it's a 1 mega ohm, then what it will do is it'll output a voltage that driving into a 50 ohm load means that you'll get 1 volt peak to peak. But when it doesn't, when it's in the 50 ohm load driving a high impedance, then you have this really strange voltage divider, which is what we were seeing earlier. So I don't know if that actually answers the question or not, but the short answer is the cable itself is not a 50 ohm resistance, it's a 50 ohm impedance. And remember that impedance is resistance with frequency. So that might help or make it worse, I don't know. And in electronics, almost everything uses a 50 ohm characteristic impedance, which means for a single signal, it's 50 ohms, but a differential signal will be 100 ohms because it's 50 and 50 on either side of the signal. It's different from video, where in video, the characteristic impedance is 75 ohms. And so the cables are going to be a little bit different and they're not usually compatible. So I'll just say that. But that is cool. That's what we want to see. So what I don't think I have a good way of like generating noise, or can I modulate? I can't modulate with noise. Although I don't know what it's doing, but that looks super cool. I should just make like a intro screen of just that. I'm just gonna leave it like that. Yeah, because I was trying to think, I was hoping I could modulate one of the channels with noise and then the other channel with noise, because then we would actually see the noise get removed. But I can't seem to, no, we wouldn't, because I'm using a phase shift. Yeah, I'll have to come up with a way to demonstrate how differential works. I don't have anything on hand, so all we get is the A minus B at the moment. But yeah. Okay. Oh, you know what? Oh no, that's right. My friend Kyle was actually trying to help me find this, because I don't know that this scope actually supports XY mode, which is unfortunate because I'd really like to use it for the Vectrix. I take that back. It has to. It has a Z-axis input. It must support XY somehow. Okay. Anyway. All right. Yeah, Happy Little PCBs has got it right. Impedance is how inductors behave over frequency. I actually did a Element 14 video on LCR meters, and we touched a little bit on impedance and frequency, because as it turns out, resistors, capacitors, and inductors are not perfect. And so their values change over frequency because they all have a little bit of the other parasitics in them. So all resistors have a little bit of capacitance and a little bit of inductance. More inductance than resistance or capacitance, but they have some. And capacitors have some resistance and some inductance in them. And so what ends up happening is when you look at them at like with a multimeter, which is a DC measurement, their value is relatively stable. But when you look at them across frequency, their values change, which is the whole point of which is the whole bane of any RF or AC type, small signal AC stuff, is dealing with frequency. Yeah, so most of the older techs do support XY. What's weird about this one, and I think what, again, my friend Kyle, he understands the 7000 series way better than I do, and he's got a bunch of modules, but he doesn't have a 7704. And our theory is that if I had a second vertical module, I could put the vertical module into the time-based module, or the time-based slot, and that would turn this into an XY mode. But I don't have another vertical, plain vertical module that I can try. What the scope doesn't seem to support is I don't think I can do XY from these two channels. I think I have to have another module in order to do it. And so, which isn't, I don't consider that a limitation by any means, because that's actually part of the flexibility of this type of frame. It's just, I wish I had one. So, yeah. Okay. What else can we do? Are the modules hot swappable? Heck no. No, they're not. However, I do think a super cool feature of this frame is, so this came out in the late 70s, and it has a switch mode power supply. And I found the Tekscope article. Tekscope was a magazine that Tech put out to talk about their instruments. So they had Tekscope, and HP had the HP Journal. I'm not trying to be biased because I worked for HP, but HP Journal was significantly better than Tekscope. But Tekscope did a much better job at getting into how instruments worked. And so they like had a lot more articles that were more like service notes. But they had an article that introduced this scope system, and they were super proud that it used a switch mode power supply, which was not a very common thing at the time. And because it wasn't very common, one feature this scope has is I could remove all 4 of the screws and pull the entire power supply out while the scope is on and make measurements on the switch mode power supply, because the cable harness was designed so that you could remove this whole thing. And what I find really interesting about test equipment from the late 70s and early 80s is they were all designed with repairability in mind. And so I was talking earlier how this is 2 modules that separates and comes apart, but it's also designed so that each of the panels come off very easily so that you can get in and make measurements. And then, like I said, if you go to like the Tekscope magazine or the freaking service manual, I guess that's really where you're supposed to go. There is tons of data on what adjustments you could make, what adjustments you should be able to see, measurement points and things like that. And so, you know, one of the cool things about equipment from that era is they were designed to be repaired by the end user. Part of it was a lot of these things were kind of testing the bounds of what people knew about circuit design. So you sort of sometimes had to understand how the actual instrument worked in order to make sure your measurement was working correctly. And the other part of it was, you know, a lot of these companies were making money on selling instruments and not service. The idea of shipping this to a service center was not really ideal to anyone, right? FedEx didn't exist 40 years ago. So I don't think they did, right? Pretty sure they didn't. It certainly wasn't called FedEx 40 years ago if they did exist. But, you know, just to let me, before everybody goes crazy about, oh yeah, you know, it's a shame things aren't repairable anymore. If you think about it, like, let's just use scopes for just a moment. Remember what I said earlier about digital scopes is they really only have 5 major ICs. The front end attenuator stage, the amplifier, the ADC, memory controller, and usually a trigger chip. I think I had a different 5 earlier, but anyway, so they got a couple of ASICs in there. You know, you could argue it's like, well, how repairable are they going to be? Those are all pretty much going to be BGA packages, and they're only going to be available from the vendor, right? And how many people really will rework their scope versus either send it in or get a new one? And so in some regard, repairability isn't as important. That said, I think modern instruments do a pretty good job of making modules to be replaceable. So if you open it up, maybe you replace the entire acquisition board. But you know, the idea that you're going to adjust a potentiometer on a modern digital scope to, I don't know, change the vertical sensitivity, I mean, that just doesn't happen. So the benefit to that is you can calibrate out a whole slew of stuff in software because there's all kinds of other equipment. Anyway, I'll just stop there. Okay. I think I'm going to start wrapping up. I mean, I'm pretty excited. We got through the TDS, was this a 350, the HP 5401, that Kenwood scope, the 1670 logic analyzer, and now my favorite analog scope, the 7704, which I'm super excited it still works. I was so nervous that this one wasn't going to make it. Oh man, I missed one. What time is it? Okay. Okay. I got it. We're going to look at this TDS. Let me find another power cord. I got an idea. I know what we're going to do. This will be fun. We're going to do a comparison. And then we'll wrap up. But let's get this one because I think this will be cool. All right. Okay, let's plug this in. And plug in this guy. And then I'll adjust the camera so you can actually see this. And then get him powered up. Watch, this is going to be the one scope that doesn't work. I bought this one right before I moved out of San Francisco. I actually met the guy at the BART station. It was super shady. I sometimes wonder if the scope was stolen. Uh-oh, it's not booting. Or is it? Okay, that's looking better. I want it to try to get both screens. Okay. Oh, shoot. I forgot there was a zoom on that. Sorry. Who set up these OBS scenes? Man, that guy was not very intelligent. There we go. Maybe up a little more. Yeah. Oh, that's not going to work. Okay. So what we're going to do, let's go put one channel into here, one channel into here. And then up here, I'm just going to hit auto set and be lazy. And then over here, I'm going to hit left, go vertical mode. And then we're going to do channel 1 only. And then, why aren't we triggering? Should be trigger B. Interesting. Left B, vertical mode, left vertical, vertical mode, left vertical. I feel like something is, did I have modulation still turned on? Oh, that's what it was, because we were playing with modulation. Okay, that's better. Okay, check that out. Okay, here's what I was thinking. Just kind of funny to look at, like, this is a 7704 from like 1979, and then this is a Tech TDS 100. And I want to say it's like, it was made, I thought it had a made date of like 2000 or something. It doesn't say on here. Yeah, because I think the firmware that came on it was like from 2000 or 99 or something. So, 30 years of difference between these two. I prefer the one at the bottom. What do you guys think? Which one do you like better? Well, I did actually at least look at like Craigslist to see if anyone reported something like on Lost and Found. And then I did a couple of searches for the serial number just to see if they show up anywhere. I don't know. The guy I met the guy I bought it from was kind of shady. Didn't really strike me as the kind of guy that would have a 100 megahertz digital scope lying around, but I got an okay deal on it. I don't remember what I paid now, but I remember at the time I was like, yeah, it's a little bit more than I wanted to spend, but it was in pretty good shape, so I figured why not. But now I see this, it actually got a chip during the move, so okay. Oh, this has an FFT? I didn't know that. Okay. Wow. Check that out. I did not realize it had an FFT. Does it have, I don't think it does, but does it have, let's do default setup, auto set. I don't think it does any decodes, right? Are we going to trigger? Did I hit auto set too many times? Rising, falling, yeah, okay. Normal, oh, edge, video, pulse. Okay, yeah, it doesn't do any decodes. That would have been cool. All right, let's hit auto set again. Okay, so that one's working. Yeah. Hey, Rootkey, thanks for the follow. Welcome to the stream. The scope on the screen on the bottom is nicer to my eyes. Yeah, actually, wow, is there some ghosting going on? There is. I wonder where that's coming from. Is it the intensity or the focus? No. We're on channel 1. Channel 1 DC. We're not doing any. I wonder why this is ghosting. Nope. Interesting. And I don't think it's the intensity. Or the focus. Nope. That's weird. Maybe it's just this particular time base is more sensitive to it. Yeah, okay. That looks okay. Yeah. A bit salty because I could really use a 4-channel scope. Can't justify the price. Yeah, that's always a tough one. People are always asking me, should they get a 2 or 4 channel? And, oh man, it's just, that's a tough one. If you can afford 4-channel, get it, but there's so few times when you need it. However, when you do need it, you do need it. Sean was asking, 7704 is a CRT? Oh yeah. Yeah, this is CRT. I mean, this guy's been around since 1979, 1978. Did this one have a date on it? Or did I just get that from the article I read? Yeah, I'm trying to remember if I found a stamp on this or one of the modules maybe that had a date, but I can't remember now. But I do know that the series itself was released in the late 70s. So the one on the top is definitely LCD, but the bottom is just a green CRT. That's why we have separate controls for focus, intensity, and then you can even turn the graticule. It has a light on it. Can you see that? Well, I was going to say I don't think that really helps much, but I think that comes back from that idea. Remember I said you could attach a film camera onto it to take screenshots. So I think that's why the graticule lights up. Power cycle to see if the ghosting goes away. Okay. Oh, maybe like a decauss? Is it maybe something like that? So let's go back to the by 10. And then let's turn the intensity down. Okay, power. And come back on. Nope, it's still there. Yeah, not sure what that's about. A little bit worried about that, but not so much. It might just be an effect of how the display works. But, you know, I'm not going to complain. It still looks pretty good. GB, you've done camera scope shops. More power to you. When I was in college, we had a digital camera that we would use to take pictures of a, you know, is their modulation still turned on? No. Yeah, okay. That's but yeah, I remember in college we had a digital camera. It was like a Mavica or something, and it would save to a floppy disk. And then we had some Tech TDS series scopes that had floppy drives in them, and they would save a bitmap, but it was so frustrating because it would take literally 2 minutes for it to save the bitmap. That I used to joke is like, I can draw the screen faster than this. But it did make for some really good lab notebooks at the time. See if it has a degauss. I'm not sure that it does. I'm trying to remember if let's change the astigmatism. I forgot what the actual name is, but I'm going to call it astigmatism. Because I do know this one, I've had a little bit of trouble with the display. I mean, it's not in the best of shape. Yeah, no, that just clearly makes it better, or makes it worse, or better, however you want to view it. Let me just check something real quick. No. Yeah, I don't know. I'm thinking it might just be an artifact of our display. Because if we go to the slower time base, well, it's there too. Okay. Huh. I don't know. I'll have to see if there's anything in the service manual about it. That could be fun. What is the beam finder? So beam finder is for literally when you don't have a good signal and you're not sure if you're even able to find if you're even on the screen. So you just hit beam finder and it just makes it easier to see where the beam is. So like I want to say, like, if I'm off screen, so beam finder tells me that I'm way off screen, so then I can bring this back down. Or if I go way too far off, okay, it's somewhere down here. So I don't remember exactly how they're implemented or what it does, but its purpose is to help you figure out where did your trace actually go. And just by viewing this, it looks like it's almost like it's taking it, it's like some form of zooming out. So I wonder, it must be changing like one of the magnets that it's using to change ghosting. Well, ghosting went away because we turned off. Well, let's try something. Yeah, no, it's still there. The ghosting it got better because I went to a different time base. It is astigmatism. I'll be darned. If it were degaussed, then text would also be fuzzy. My only reason I want to challenge that comment is because the way that the text gets drawn is, I believe, with a separate electron gun or a separate beam source. I'm not positive that that's the case, but it could be. There's something about the way that actually, let's put the differential module to ground. Yeah, no. I mean, we're not chopping and we're not doing alternative. So yeah. But anyway, where I was going is I have to go back and look at the article. There's something about the way they do the text is like unique or different, and I can't remember what it was. Yeah, we're not, yeah, it's not the differential because we're on the regular channel. I mean, the other thing we can do too is see if it's a vertical problem. So we'll go to channel 2. And then we'll show channel 2, trigger on channel 2. So channel 2 is still seeing it. What we can do is if I go into the differential channel or differential module, we will get a trigger even though we're only halfway. So I don't think it's related to either of the vertical channels. I really do think it's an artifact of the screen. Huh. Well, that's interesting. So I can't show this on camera, but it's almost like there's a 3-dimensional effect because on this angle, I see multiple copies of the waveform. And I don't see them there. But here I definitely see it. So since we're almost done, I'm going to see if I can get the camera to show that. Because it's really strange looking. We can get this guy out of the way. Yeah, you can almost see them. Okay, I'll leave it alone so that it gets a little more stable. But notice how there's like individual lines. That's weird. That is weird. Fair question. Yeah, that's not it. Let's shut this guy off. I'll even move the generator away from it. Yeah, I don't think it's interference, but there's just something about that pattern that just kind of looks, I mean, that just kind of looks a little, I'm not sure what's going on. It looks like an infinity mirror type of effect. Yeah. You know, one thing I'm thinking about, because there is a glass panel in front of the CRT and it is cracked. And so I wonder if the cracked cover panel is causing a problem. Interference from the other scopes. Yeah, right now, the only thing that's, I mean, other than the other equipment around here, right now, the only thing that's on is the generator and the scope. And the generator, we can even move it. Okay, I guess my phone was over there too. I mean, I can't imagine anything is interfering with it that close. I mean, I don't think it's interference. Refraction, I'm leaning towards it's refracting, and I just wonder if it's normal or if it's because because that front cover's cracked. Regardless, it looks freaking cool, right? I mean, let's make sure we acknowledge the most important aspect is that just looks cool as hell, right? Let me turn that down a little bit. That's so bright it bothers me. Okay. That's awesome though, right? Yeah. But see, the fact that the text isn't doing it, I can't remember what it was, but I remember reading about it. I'm like, oh, that's a really clever way to generate the text. Because the text gets generated at a different frequency than the waveform gets painted. And so it's almost like it has its own electron gun to do the text, because it's usually independent of the waveform update. It was the 70s. They had to make the scope groovy. All right, I think RJ finally figured out the real answer. Okay, GD, I'm not positive, but to me, Gaussian blur is funny since analog scopes, their analog bandwidth is a low pass single pole filter, and scope manufacturers, we say that the front end of an analog scope has a Gaussian roll off, and so it's quite funny to say, yeah, that's an example of Gaussian blur. That's good. That's good. All right. Well, cool. So we got the scopes checked out. I had a lot of fun. I'm super excited to finally do something from the new lab, even though it has a lot of work to go. Like I said earlier at the beginning of the stream, this background isn't even going to be here forever. It's only here so that it's not a blank wall. But yeah, and then let's see. So next Monday, hopefully the benches show up. So by next weekend, I'll have actual benches with all like my normal equipment set up. So that'll be pretty cool. And then I've got some shelves coming so that I can put stuff like my scopes on shelves around the lab. And let's see. Yeah. No, I don't. No, I don't think it'll work. I want to try something really quick, but I think I'm too far away that it's not going to work. So let me try this. Pi SSH. And then okay, let's see. Nope, too far away. Darn it. Okay. Sunday, I will show this really cool thing. Wait, what? What? Really? You think so? Yeah, okay. You don't have a connection, you liar. You made me think you had a connection. Yeah, okay, it's not connected. So what I'll show, or you can go back and look on Wednesday, we actually played with the thing that's like right here. And it's an on-screen display of my DMM, which thank you to Tizboyo and Geekboy. They took my early crude Bluetooth code and turned it into that. However, the Pi that I'm using is upstairs, and so this can't connect to it, so I can't show this yet, or show it today. However, if you go to twitch.tv/baldengineer and look at videos, and then look for the broadcast on Wednesday, we played with that all on Wednesday, and it's super freaking cool. I realized, I just totally forgot that the Pi, I need my Pi to do that. So yeah, so I'll try to show that off on Sunday, because I do want to show that off. I'm super excited about that. Multiple things. Okay, let's close that. So, okay. All right. Sorry, catching up on chat before close out. Dr. J said it might even be a psychedelic effect left over from the 60s. That could be. Hey, Sean Pugman, thank you for finding the channel. Please make sure you guys follow. I do streams on Wednesday, Friday, and Sunday. And then I also have a couple other things, like for example, if you go to Element 14 Presents, I have a weekly show. I shouldn't say weekly. I host a show that's showed on Wednesdays there. We are in a little bit of a weird place because I've run out of episodes because of my move, but those will get going again. And then there's also AddOhms that was my YouTube channel that I will actually get back to posting in the not too distant future. Now that I have a dedicated studio/lab, well, once it's set up, getting back to doing regular videos are going to be so much easier, because in the past, all I had was one table and that was it. And I had to do my work and shoot the video and do live streams all from one location, which meant like every couple of days, I could only do one thing. But I'm okay. If you guys don't know, we also do have a Discord. So if you go to AddOhms.com/Discord, that'll redirect you to the Discord server. It's a great way to keep the conversation going. So feel free to join there. And then what else do I? Yeah, actually I need to add one for AddOhms. Okay. All right, I'm going to wrap up. Again, I want to thank everybody for joining tonight. I had a blast going through and just testing out these scopes. Very soon we'll get back to Friday nights. I want to get back to working on vintage or retro video game systems. Just a preview, sneak peek. I just ordered some composite mods for the Atari 400 and an Atari. I hope Atari 7800. I just realized I might have ordered it for the 2600, but I don't have a 2600. But I do have an Atari 400. So anyway, we will, in the not too distant future, we'll get back to doing some soldering stuff. And like I said, on Fridays, I like to do retro game systems. So we'll get to doing that. On Sunday, we will get back to drawing the Apple IIgs schematic in KiCad. And next Wednesday, we'll have to wait and see. I'm not sure what we're going to do yet. So thank you again. Join the Discord, and I'll see you guys later. And again, everyone in chat, thanks a bunch.